ఆర్ శ్రీనివాస్ జీ చాలా పెద్ద పెద్ద ఐఐటీల్లో ఎన్ఐటీల్లో స్పీచెస్ డెలివరీ చేస్తుంటారు వీళ్ళంతా. యూ హ్యావ్ టు బీ కాషియస్, యూటిలైజ్ ద టైమ్. శ్రీనివాస్ జీ.
Good morning to all. Yeah, I am R Srinivas from Outreach Facility. We have here our Group Director, Fyzy sir. So, anybody interested in coming to Outreach Facility, they can approach our Fyzy sir. Okay, the Outreach Facility is at JD Metla. Are you aware of JD Metla? Balanagar. So, you can come to JD Metla. So, there we have a lot of like scale models. We have live streaming of real-time ground station. We have the different kind of posters of NRSC activities. So you please come down. Now coming to the lecture here, we have a small PPT related to the ISRO activities. As you know, Dr. Vikram Sarabhai, he was the founder of ISRO. ISRO started way back in 1962 actually. Earlier it was called INCOSPAR. Now it is called actually in 1969 ISRO started. ISRO, Indian Space Research Organization, started in 1969. So as you can see there, a small church. Are you able to see the church? So we are not having sufficient funds, no building, no proper infrastructure. So in that particular church, the research and development was being carried out. So it was given by Bishop Bernard. The Tumba area what we have presently, it is given by Bishop Bernard. And to the bottom left corner, you can see Dr. Abdul Kalam. Are you able to identify him? Abdul Kalam. So he is servicing the sounding rocket. And during that time, you can see the satellites being carried on bullock cart, and also the satellites being carried, the rocket being carried on the bicycle. There was no early warning system. As you are aware, India is a peninsula. So during 1960s, lot many people were dying because we are not knowing from which particular direction the cyclone is coming and is going to hit the coastal states. So the government of India during that time wanted exactly two things, two objectives. One is how the satellite data will be useful for the common man, and the second is how the satellite data will be useful for the fishermen. So these two primary objectives, ISRO started the journey. Now, if you see the total map of India, in that about 21 centers are there, ISRO centers are there, but I will be not talking about all the centers. I will be talking about the major centers. So you can see to the south side, there is a center called VSSC, Vikram Sarabhai Space Center. It is named after Dr. Vikram Sarabhai. So it is the main focal center for manufacturing of rockets and launch vehicles. Okay, so all the design and development of rockets, launch vehicles is being conducted there, and you have the different kind of propulsion systems, everything is available. So the rocket is nothing but it is a transport mechanism. It is a transport mechanism to carry the satellites into space, isn't it? Now assume that the rocket is ready. Now what else we require? We require these satellites. Okay, so we have another center called the Space Application Center, wherein you have all the design and development of the payloads, the photo, the cameras, the solar panels, the devices, the power supplies, the antennas, transmitters, each and every part of the satellite is being manufactured at the Space Application Center, Ahmedabad. Now the rocket is ready, the satellite is ready. Will you launch the satellite immediately? No, because you need to test it. Otherwise what happens? Your total time and money will be wasted. So what we do is we bring the satellite to a center called URSC, which is in Bangalore. So we bring the satellite there and we do the test. So it is our own satellite, isn't it? So now we know what are the specifications of the satellite, what is the input to be given, and what is the desired output which we are going to get. So we do the kind of simulations, the different kind of simulations. So for example, if you have the TV at home, the LED TV or the LCD TV, so if you switch on the TV continuously for 3 months, what will happen? Maybe it will like like it get heated up or it may fail. Why? Because the kind of components you are using, they're all commercial grade components. Now you may be seeing in the airport and also in the railway stations. So there we have the TVs continuously running, but they don't fail. 24/7, 365 days they are working, isn't it? So the kind of components being used in that particular TV, that is an industrial grade. Now assume that you are going to have the kind of Siachen Glacier or Himalayan region where you are going to use some kind of RF equipment or the radio equipment. So in that particular area, the kind of components which are required are the military grade components. Okay, so similarly, the satellite, it is going to be placed where? It is going to be placed in the space, isn't it? So we have to make the satellite space worthy. That means the kind of components required, that is the space grade components are required. That is why that is the reason why the satellites are so costly. Okay, so we need to do the different kind of tests. Like we have the environmental tests, then we have the electromagnetic radiation tests. So the satellite is subjected to different kind of radiation tests, electromagnetic radiations, and the environment. We have the extremities of environment in the space, isn't it? So for instance, if you see the environmental test, IS 9000, and if you take the electromagnetic radiation test, IEC 61000. This is a small example I'm telling. So we have so many kind of like different tests, thousands of tests will be there, and we have a separate cell called the System Reliability and Quality Assurance. So these our ISRO engineers will be like testing all the satellites. So testing all the satellites, and once they are satisfied that yes, this satellite will work in space faithfully without any problem, then we'll shift the satellite to Sriharikota. We'll shift the different stages of the rocket to Sriharikota. You are aware where is Sriharikota? Andhra Pradesh. So we have two different spaceports there. We have Spaceport 1, Spaceport 2. So Spaceport 1, we launched the PSLV, and the Spaceport 2, we launched the GSLV. So once the satellite and rocket is sent to Sriharikota, then all the stages are assembled. On the top of the rocket, we will be putting the satellite. Okay, that is called the payload fairing. In the payload fairing, the satellite will be kept, and the launch starts. The countdown starts. So now once the countdown starts, Newton's third law, every action has equal and opposite reaction, isn't it? So here the action is you are burning the fuel, combustion. The fuel can be a solid fuel, it can be liquid fuel, it can be cryogenic fuel. So because of that action, the reaction is it generates a lot of thrust and slowly the rocket lifts up. So once the rocket lifts up, the first stage burns and goes to a height of around 100 kilometers, then second stage burns 200 kilometers, then the third stage burns 300 kilometers. Then finally, when it reaches the desired altitude, we'll take the example for remote sensing satellite now. So generally all remote sensing satellite, the range will be around 500 kilometers to 800 kilometers. Assume that all the stages are burned and it has gone to a height of around 800 kilometers or 600 kilometers, the satellite is pushed into space and it will be revolving like this on the earth. This is the earth, north pole, south pole. So the satellite is pushed and it will be revolving like this. Okay. So the speed of the satellite in space, it is about 4 kilometers per second. That means it will take around 1 hour 40 minutes to complete one revolution around the earth. So this is the process. So once the satellite is sent into the space or pushed into the space, it keeps on rotating, then our work starts. We are NRSC, National Remote Sensing Center, Hyderabad. We are the prime focal station, ground station, which is situated at Shadnagar. It is like near to Bangalore highway. From Zoo Park, it is around 50 kilometers away. So we have a station there, and there we are acquiring all the remote sensing satellites. So any remote sensing satellite which is launched from Sriharikota, that particular data will be received at that particular station. We have lot many antennas, we have lot many infrastructure. So because students are not allowed there to go to Shadnagar, we have arranged a facility called the live streaming of real-time satellite tracking and live streaming of real-time data display and also the station control computer countdown. So you can come down to GD Metla to see the live tracking of the satellite passes. Now if you broadly categorize the assets by what we have, you can categorize into one is the launch vehicles or the rockets. The next is the category called the communication satellites. So you're all using the communication satellites, point-to-point communication, the internet, broadband, everything, it is possible with the help of communication satellites. Then you have the IRS series of satellites, Indian remote sensing satellites. Then coming to the IRNSS, Indian Regional Navigation Satellite System, or the NAVIC. Okay, it is named as our constellation of satellites is called the NAVIC. And apart from all this, again, we have the space missions. You may be aware of the ISRO space missions, like the Chandrayaan-1, Chandrayaan-2, Chandrayaan-3. Again, we have the Mangalyaan, we have the Aditya L1, we have the Astrosat, we have the Exposat. So many different missions are there. So, a little bit of history. Now, you may be seeing on the top side, that is the first ISRO, that is a satellite, that is a Aryabhatta. Then on the down, you can see the first Indian remote sensing satellite, it is a IRS-1A. So, this particular satellite, you can see, it is launched from, Cosmodrome. It is from Russia, Baikonur Cosmodrome, Russia. So, why? What was the reason? The satellite, we were having the ability to design our own Indian satellite, which is weighing around 1200 kg, but during that time, we were not having the capacity to lift up so much of weight. So the weight of the satellite was 1200 kg, but during that time, our capacity was only 40 kg. So 40 kg, it is a SLV3. With the help of SLV3, only 40 kg only weight we were able to lift up. That is the reason we have paid money to Russia. During that time, it was USSR. We paid money to Russia, and we have launched our Indian remote sensing satellite 1A. So since then, we are receiving the data from the remote sensing satellites, IRS-1A, then we have the IRS-1B, 1C, then 2 series started, and presently the 3 series is going on. So here you can see the different milestones of ISRO. So the first one is the SLV-3. So SLV-1 failed, SLV-2 failed, and SSC-3 was successful, and that was the first rocket from Indian soil. So we could lift off a weight of our 40 kg. Then what we did, we augmented the satellite, we redesigned the satellite, that is called the augmented satellite launch vehicle. With that particular capability, that is a solid fuel, we could finally lift off weight of 150 kg. But that also was not sufficient. Again, what we did, we again designed a PSLV. This is called a hybrid kind of thing. PSLV is like a multiple, it is having the solid fuel, the liquid fuel, then solid fuel, the liquid fuel. That means 4 stages are there. Alternate stages we have solid, alternate stages we have liquid. So with this PSLV, the Polar Satellite Launch Vehicle, we are able to send the satellite, which is weighing around 2000 kgs or less than 2000 kgs. That means all the class of remote sensing satellites will be able to send with this particular PSLV. But now coming to the communication satellites. The communication satellites are more heavier than the remote sensing satellites. So what we did, again we modified the design. And that is the GSLV, Geosynchronous Satellite Launch Vehicle. That is the first one, that is the GSLV Mark II. So with this particular launch vehicle, 2200 kg, we were able to again lift off. Again, we have redesigned the GSLV Mark II to GSLV Mark III. So this particular rocket launch vehicle, we are capable of lifting up to 4000 kgs. 4000 kgs. So again, we have remodified this particular GSLV Mark III into LVM-3. So the LVM-3, the Chandrayaan-3, it was with this particular GSLV Mark III, we are renamed as LVM-3, and we are able to successfully launch the Chandrayaan-3 satellite. Okay, now to the right side you can see here, this is the GSLV exploded view. So the first stage is a solid fuel, and the second stage is a liquid fuel, and the third stage, top one is a cryogenic fuel. And the top of that is called the payload fairing, where you keep the satellite. Suppose you want to send a satellite into space, you keep the satellite in that particular location. Assume that you want to keep a telescope, for example. You can keep the telescope in that particular location. If you want to send an astronaut, the crew module has to be kept in that particular location. So these are the launch vehicles. So SLV and ASLV, we are not using. That is obsolete now. And presently we are using the PSLV, GSLV and the LVM. These are present. And in the future, we are going to use the SSLV. So SSLV, the small satellite launch vehicle, which is having the capability to lift off 500 kg. Now what is happening is, because of the advent of latest technologies, everything is getting smaller. Okay. And the space market is so high that people are not ready to wait for months together. They want to bring the satellite and immediately you have to launch within 2 to 3 days. That is the kind of demand. So for that, to meet that particular demand, we have brought the SSLV, small satellite launch vehicle. And the next is the RLV, reusable launch vehicle. So because the kind of fuel is very costly, so 1 kg of fuel costs around $2,700. That is a per kg. That is the kind of cost. So you want to have the kind of budgetary kind of considerations, low cost considerations. For that, we are using the RLV. RLV is a reusable launch vehicle. So what it does is the rocket will go and put the satellite into space, again come back. Okay, this is the kind of technology what we are planning. So here you can see the left side, we have the PSLV, then the GSLV, and now on November 14th, we wanted to put a satellite, a communication satellite which is weighing more than 4,000 kgs. So that is about around 4,500 kg. So we are not having the capability. So what we did, we took our communication satellite and given to SpaceX. So recently, day before yesterday, November 18, it was launched, GSAT 20, I think, yeah, GSAT N2. So that was a satellite which is a communication satellite. So we have given our satellite to the US SpaceX for launching our satellite, communication satellite. And now coming to the right side, the new generation launch vehicle. So you can see here, if you want to put the different kind of heavy satellites, you want to put, then you have to use the NGLV. The kind of fuel what we are using presently is the cryogenic, solid and liquid. Now we want to go for the carrying the more weight. So for carrying more weight, we are going for the methalox engines, that is a methane engine. And we are going for the kerosene engines, semi-cryo engines it is called. So semi-cryo engines is the latest technology, and we have the methane engines. So these are one of the latest. So our target is, we want to put the satellite in LEO orbit for about 20 tons. And also in the GTO, that is a geosynchronous transfer orbit of 9 tons. And the next version is the heavy, the NGLV heavy. So 30 tons and 12 tons. So this is the kind of technology we are expecting in the coming years. Now, coming to the different kind of fuels what we have. So you can see the solid fuel, that is a HTPB, and we have the liquid fuel, UDMH, and we have the cryogenic fuel. So what is that cryogenic fuel? It is a combination of oxygen and hydrogen, isn't it? So what is the combination of oxygen and hydrogen? Yes, what is the combination? It is nothing but the water. That means water is also a rocket fuel. So may be aware of 1969, the Apollo mission was there, Apollo 11 mission was there, and they have the first man to land on the moon, Neil Armstrong, and afterwards the last mission was in 1972. So after that, almost 50 years, nobody was interested in going to the moon, isn't it? Then in 2008, Chandrayaan-1, with the help of Chandrayaan-1, we could find out that there is water ice trapped, particularly in the North Pole and South Pole of the moon. So because of that, again people started getting interest. Why? Because water is available. That means water is nothing but rocket fuel. Water is, if suppose you electrolyze water and separate oxygen separately and freeze it to around minus 183 degrees centigrade and the hydrogen to minus 250 degrees, it becomes a rocket fuel. And also oxygen is required for human habitation. That means the moon will act as a base. It will act as a base station, and you can build colonies there, and again you can go beyond the moon. So that is a kind of planning and all. So you must have seen the recent moon missions, the American mission, Peregrine. Then we have the Luna mission of Russia, China mission. So many countries are again going because now there is a potential there. There is water availability potential is there. So groundwater, the water is like trapped like ice. In the ice it is trapped. That is the reason why people are going. Next. So some of the achievements I would like to highlight. You can see the first satellite Aryabhatta, then the first remote sensing satellite, that is IRS-1A, and the first communication satellite in 1982, way back in 92, and the first launch vehicle SLV-3, and we have the PSLV, that is which can carry about 2,000 kgs weight, that is 1993, and the first communication satellite is in 2001, and the first SSLV, which can carry a weight of about 500 kg, that is SSLV, and we have the navigation satellites. Here you can see the navigation satellites, we have the two different bands, L5 band and L1 band. So during 2013 to 18, we were not in a position to send the satellites in L1 band, that is a commercial band. So that is the reason we wanted to protect our country first. So what we did, we wanted to provide the kind of timing systems for our army, military and navy. So for that, what we have done is we have given the L5 band. First we wanted to protect the country. Then again, now only we are started going for the L1 band. So we have the two L1 band satellites right now in space. Okay, so that is a commercial band. In the future, maybe in the future, the whatever mobiles you are going to get, it may have the kind of L1 GPS also. Now coming to the PSLV C-37. So we are the first country in the world, way back in 2017, we are the first country in the world to launch 104 satellites at a time. No other country in the world was able to do that. That was a very remarkable feat as part of the ISRO. So now coming to the Chandrayaan-1. So that was way back in 2008. And again we have the Chandrayaan-2. In Chandrayaan-2, the orbiter was there. So the orbiter took the lander. So inside the lander we had the rover. And we started from the Earth. We made some different circles around the Earth. Again, we accelerated the speed and we have gone to a speed of around 28,000 per kilometers per hour and we reached the moon. So after reaching the moon, again we started decelerating. And finally we tried to touch down on the moon. So during that time, what happened in Chandrayaan-2 is there was a software glitch, software error. There was a bug in the software. So because of that, what happened is the lander lost control with the control room at Bangalore and also it lost contact with the orbiter. So because of that, it crash landed on the moon. So it was a partial success. Chandrayaan-2 was a partial success because the orbiter is working fine. Now also the orbiter is working fine and taking beautiful photographs of the moon. Now coming to the Chandrayaan-3. You are aware of Chandrayaan-3. We started on July 14th. And again we landed on the moon August 23. So August 23 we successful landed on the south pole of the moon and we became the first country in the world to land on the south pole of the moon and fourth country in the world to land on the moon. So that was a remarkable success of Chandrayaan-3. Then coming to the Aditya L1. So not only moon, we are also trying to see the different kind of sun also. Aditya is nothing but sun. So why you want to monitor the sun? What is the requirement? Because the earth climate totally depends upon the sun. What are the disturbances happen on the sun? Like the solar mass ejections, you have the solar flares, solar flush, they are directly affecting the earth. So in December 2022, what happened is the solar burst, it directly hit the Sydney in Melbourne. A lot of crores of navigational equipment was destroyed. So with the help of the kind of data what we have, the critical data what we observe from the sun, we are going to take that and we try to develop models so that we can avoid the such kind of issues in future. So now coming to the what is the L1 point. The earth is there. This is the earth. The end point gravity of the earth and the end point gravity of the sun. That merging point is called the L1 point. So at that L1 point what happens, the gravity is very, the atmospheric drag, the gravity is very, very less. So that particular point you can maneuver very easily and you can park a satellite and it will directly seeing the sun. That is the main advantage of the L1 point. Now coming to the Gaganyaan. So you may be aware of Gaganyaan. Are you aware of Gaganyaan or not? So Gaganyaan is we want to have our own rocket, our own astronauts, our own space food, our own crew module, everything our own. We don't want any kind of foreign collaboration or any foreign components. So we want to go to the space, stay there for 3 days. Our astronauts will be going and staying there for 3 days. They'll be rotating around the Earth, do the scientific experiments, and again they'll come back. And the crew module will be coming and splashing in the Bay of Bengal, and our Indian Navy will be going and retrieving them. Okay. So that I'll be telling in the future next slides and all. And next is the NISAR, NASA ISRO Synthetic Aperture Radar. So this is the costliest satellite in the world, remote sensing satellite in the world. So you may be seeing that why that NASA is coming to India, because we are also pioneers in the kind of active remote sensing or the microwave remote sensing. We are also pioneers in that. So that is the reason why the USA, the NASA is coming to India and they are making the L-band SAR and we are making the S-band SAR, and that is the output, the NASA. So this is particularly for monitoring the Earth surfaces, the changes in the Earth surfaces. The application is that. So we are going to launch in the near future in 2025 or so. Next. So here you can see the results of Chandrayaan-1. Okay, so what we could achieve with the help of Chandrayaan-1. One is the discovery of water on the moon. The second thing, you can see the different that 3D image, what we are, the photographs taken by the Chandrayaan-1, and we could see that the detected the different signatures of aluminum, silicon, and the different elements. That means the precious elements what we are having. So earlier it was like, it is like a space exploration, but now it is not like that. It's like space exploitation. So whoever goes, whichever countries goes first, he will put a flag there, and it is, they name that particular region and point and all. So when we have landed on the south pole of the moon, we have named our particular, that region as a Shiv Shakti point. You may be aware of it. Next. So this is about the Chandrayaan-3, how we went to the moon. So we made a round, we made a circle around the moon, we increased the speed. Again the second circle, we increase the speed, second orbit, third orbit, like that. Finally, in order to go to the lunar transfer orbit, the LTA it is called, the lunar transfer injection orbit, you need to increase the speed, then only you will be able to go to that particular orbit. And once you are going to accelerate around the earth and slowly decelerate on the moon, and finally the touchdown takes place. So this is the Chandrayaan-3 Shiv Shakti point. So what is the results? What are the main results? I am listing a few. The first result is that the Chandrayaan, the sensor called the Chaste, we could find that on the surface of the moon, the temperature is 60 degrees. But if you go just 10 centimeter below, that means only this much, 10 centimeter below, the temperature is -10. That means the isolation, it is a very good insulator. That means 70 degree difference we are going to get with the help of Chandrayaan, this particular finding out of this particular sensor. So what is the benefit of it? What is the reason is we can dig tunnels and all, we can have a very good insulation for that particular thing and all, and you can make colonies there, you can stay there. And the next thing, the other finding is you have some metals like the sulfur, aluminum, iron, chromium and all. So a day may come that the earth we are using the resources, because you are continuously taking the oil, you are continuously taking the water. A day may come, but when the total resources on the earth may get depleted, then you have no other alternative but to explore for other particular kind of planets or some kind of different locations. So now we are planning for the Chandrayaan-4. So what is Chandrayaan-4? Chandrayaan-4 is nothing but we want to go to the moon again and bring the samples from the moon. So this will have a propulsion module will be there, again a transfer module will be there. Then after the transfer module, again there is a re-entry module attached to that particular transfer module. Then finally, we have a lander and also the ascender. So what happens is we are having a capability of around 4,000 kgs. So we will be sending in two different, stack 1 will be sending in one particular launch, and stack 2 will be sending in some other launch, and again in the space we will be docking that particular satellite, Chandrayaan-4. And the lander once is landing on the moon, surface of the moon, after collecting the samples, again here the requirement of the AI technology, the requirement of the robotics come into picture. Because the samples are not readily available on the moon. You have to drill the moon and take the different kind of materials, isn't it? So once you take the materials, the regolith, whatever it is called, so then again you have to dump into the transfer module, dump in the ascender, then the ascender will get lifted off from the moon, and again it will go in and join the transfer module, from the transfer module again to the re-entry module, and the transfer module, when it comes to the earth orbit, again they get separated, and only the re-entry module comes into the sample module, or the re-entry module comes into the earth. So this is the brief outcome of the Chandrayaan-4. So now you can see what are the mission objectives of Gaganyaan. One is we want to demonstrate human spaceflight capability, to develop indigenous space technologies, that is crew module, service module, space suit and launch vehicle, and to conduct the different kind of experiments. So what are those experiments? Space biology, space physics, microgravity, research, astronomy, life support systems, navigation and control. So these are some of the scientific experiments what we want to conduct. And also you may be aware we are going to have a separate station called the Bharatiya Antariksh Station. So presently we have one international space station, which is a combination of different countries. They are maintaining that particular international space station and doing the kind of experiments. So we would like to have a separate Bharatiya Antariksh Station, and we are having a target. It is a long-term target that is around 2035. We want to make that particular station. Here you can see on February 28, National Science Day, our Honorable Prime Minister has declared the names of these particular astronauts. These are the pilots. They are the test pilots. They are the test pilots of the Indian Air Force. So all the 4 people are selected, out of which 3 people will be going to space in the Gaganyaan project. So this is the Gaganyaan crew module. You can see the crew module, and inside you can see the astronaut just lying down, and that is the crew module. And below that you have the service module. The service module is there. The total Gaganyaan rocket, it is called the HRLV, Human Rated Launch Vehicle. So you have the solid stage, you have the liquid stage and the cryo stage, and on top of it you have the crew module, and on the total top you have the escape system, that is a safety mechanism. Suppose something happens, that particular thrust motors will eject immediately, and they can escape from that particular rocket. So this is a safety precaution what we are taking. Next. So the Gaganyaan is almost ready, and maybe in the near future we will be able to see the Gaganyaan launches. So what we are planning is, first launch will be uncrew mission without any pressurization of the chamber. The crew chamber is there, that will not be pressurized. Then again the second launch will be pressurized with a robot called the Vayomitra. The Vayomitra robot will be there, and it will be sent along with the Gaganyaan mission, and that robot will be there in the space for 2 to 3 days. It will do the experiments, again come back. Then again one more mission will be doing, the repeat mission will be doing. So once we are confident about all the missions, then only we'll be sending our astronauts. That is the 4th mission we'll be sending with the help of this particular Gaganyaan. Next. Now, so one of the main objective of this particular Gaganyaan is space tourism, as I said. So earlier, maybe 10 years back or 15 years back, flight travel was a very costly affair, isn't it? It was a costly affair. But now it is very cheap. A common man also is able to go. Similarly, space tourism is also having so much of potential. So presently, Elon Musk with the SpaceX, he's taking people, he's charging millions of dollars and taking the people to a height of about 100 kilometers, and there again you will be experiencing the microgravity experience about 200 seconds. You can see there, again you can come back. This kind of technology, it is a vertical taking off and vertical landing. The rocket will be going vertical, again it will come back. So this kind of space tourism is very much in demand. There is a lot of market potential. So with the help of the Gaganyaan, we are also planning in this particular mission. Next. So this is the Bharatiya Antar Station, what we are planning. That is in 2035 we are going to launch it. The first module, the number 1 module, that is a base module, we are going to launch in around, this is all a kind of statics given by our chairman. So it may vary early or far and all. So the first module, it is like a base module, and that is the second module is a core module, and the third module is a lab module, and the 4th module is the science module, and the 5th module is a control module. So this is a normal, like what we are planning to have the Bharatiya Antar Station in space, that is in a long-term plan, that is 2035. Next. So last year there was a lot of success in the 2023. So you can see first in the SSLV D2, that was a success. Then LVM M3. So we have launched about 72 satellites which are belonging to the Europeans, belonging to the OneWeb technologies. Are you aware of OneWeb technologies? So this is a European company. So you may be wondering why that European company is coming to India for launching their satellites. So earlier we were going to the European Space Agency, ESA. European Space Agency, it is called the ESA. Earlier we were going and we were paying money. But now you can see those companies, European companies are coming to India for launching their satellites. Why? The reason is cost effectiveness, budget. So we are very, very less in comparative to the entire world. We are very cost effective, almost 20 to 30% less. In spite of the transportation of all the satellites, the logistic arrangements, everything, if you take care in all the budget considerations, still we are cheaper. That is the reason why the foreign countries are coming to India for launching their satellites. Then the next, then you can see in April, again we have launched about 6 satellites belonging to the different countries like Japan. Okay, so this particular launch, we had about we got a revenue of 2,000 crores. So in the last year, if you can see the total number of like amount what we got, the budget what we got is around 20,000 crores. We earned this much of foreign exchange. The foreign exchange what we earned is around 20,000 crores last year. So again, you can see the in May 2023 again we launched our Navig satellite, that is an L1 band. So we have two different satellites now presently working. That is satellite number 1 and 2. That is the like Indian GPS. Next. So you can see how the space reforms are like changing. So now we have a regulatory body called the InSpace. InSpace is the regulatory body, and we have the NISIL, New Space India Limited. So we are going to commercialize. So you can see how we are planning, we are targeting the different, the economy. So presently the 8 billion, and again we are targeting in 2023. Then again the final in 2047, we are planning of so much of amount. So there is a lot of scope for students like you, for like entrepreneurs. As Satheesh Reddy sir told, there are so many 1,15,000 companies, entrepreneur companies are coming. So people are trying to do innovative ideas. So particularly all these projects, whatever I told you, we have about 31,772 crores budget is allotted already. So it is given to 4 different kind of projects. Chandrayaan 4 is there. Okay. Then we have the NGLV. Then we have the Gaganyaan. Then we have the Venus mission. So for all these, we require the different kind of technologies, innovative technologies which are used, which are really required for all these things. So definitely the industry growth will be there, and it will be benefiting lot of entrepreneurs. Next. Now, so till now I have talked about the total space sector. Now coming to the NRSC part. So what we do, National Remote Sensing Center. So we receive data from the remote sensing satellites. On the top you can see there, so the satellite is moving around the globe from North Pole to South Pole. And it is for 1 hour 40 minutes it is covering one particular area. Okay, so at the bottom you can see the geostationary satellites. So here you can categorize the different kind of satellites into LEO, MEO and GEO. LEO is a low Earth orbit, that is height around 600 kilometers. Then the MEO is a medium Earth orbit, that is around 20,000 kilometers. Then you have the GEO, the 36,000 kilometers. So the right side animation what you are seeing is the GEO. Assume that this is the Earth and this is the Sun. This is a satellite. So at this particular distance of 36,000 kilometers, what happens? The relative motion between the Earth and the satellite both are same. That means they are seeing the same area. So this is nothing but like a parking place. So we have many geostationary satellites. Geostationary satellites are nothing but the communication satellites. Next. So what NRSI is doing, the remote sensing. So what is remote sensing? So what happens is when sunlight falls on the Earth, okay, so you have the different objects on Earth. We have the white color, we will have maximum reflection. You have the black color, maximum absorption. So different colors will be there. So these reflections are again received by the satellite. And where is the satellite? Satellite is kept at a height of around 600 kilometers. At that particular distance, what happens? The payload camera, it will receive the optical energy, and finally it will convert that optical energy into the analog voltage, and finally the analog voltage we are again transforming into digital A to D converter. Then after doing the A to D converter, then again we have the different kind of techniques like the modulation techniques or the encryption techniques or the randomization. All the different kind of things will be sending, and finally the data will be transferred from the satellite. It will be transmitted from the satellite to the ground. So at the ground we have a big parabolic dish antenna with a high gain to noise temperature. We will be receiving the data from the remote sensing satellite. Next. So this is a ground trace of the satellite imagery. Next. So you have the different kind of sensors, the active sensor and the passive sensor. The main advantage of the passive sensor is, the main advantage of the active sensor is like it is all weatherproof data, irrespective of any day, light or night and all, it will be working and all. So this is particularly useful for the disaster management, the active sensor. But the passive sensor has its own disadvantages. Where during the cyclone and all, you will be not able to see the ground and all. So because of that, it is not useful. Next. So we have fleet of active sensors and passive sensors satellites. So you can have the OceanSat, Cartosat, RISOSat. These are the passive sensor satellites which are dependent on the sunlight, natural sunlight. And we have the RISAT is the active sensor. So this is the coverage of the ground station. So from Shadnagar, Hyderabad, you can see maximum of 3,600 kilometers. That means because of the ground surface, because of the curvature of the Earth, the communication has to take place like the antenna should be able to see the satellite and the satellite should be able to see the antenna. So because of the curvature of the earth, so maximum to the western side you can see up to the Somalia and the UAE, Dubai and all, and in the northern side Turkmenistan, Afghanistan you can see, and in the southern side Indian Ocean, and the eastern side you can see Vietnam and Indonesia. So this is a simulation of how the antenna tracks the satellite. So when the satellite comes into the vicinity of the ground station, automatically the antenna will be rotating and it will be targeting the satellite. That is called the auto tracking of the satellite. So this is a typical pictorial view how the data transfer takes place. So when sunlight falls on the earth, it is getting reflected, and from the satellite again it does the packeting and all, and finally the data is transmitted from the satellite to the antenna, and the antenna receives the data, and finally we are generating an interrupt, and we are displaying the data on the screen, and also we are recording the data in the computer. So these are the different kind of antennas what we are using at Hyderabad. We have the 7.5 meter and 7.3 meter and the 11 meter antennas used for different purposes. These are the different bands what we have, what we are operating. So there is a body called the Wireless Planning Commission. So suppose you want to receive any data from any satellite, you need to take permission from that particular body. It is in Delhi, in the Wireless Planning Commission. Suppose you want to receive the data, you want to transmit some kind of data, you have to take the permission. NRSA also is receiving the data, particularly EC students. So NRSA also is taking the data in these particular bands, that is the L band, S band, X band and Ka band and Ku band. So the L and S band, whenever the data rate of the satellite is less, so we are using the L and S band. Suppose the data rate of the satellite is high, we are going for the Ka band and the Ku band. So the first Indian remote sensing satellite, that was around 5.2 megabits per second. That was the data rate. It was in megabits per second. But now the current satellite what we have, the Cartosat, it is around 1.44 gigabits per second. You can see the advancement of technology and the data rate, the resolution also is increasing, and we have the different kind of bands here. Next. So not only we have the station at Shadnagar, also we have a station at Antarctica. And Antarctica we have station. We have kept a station, why there? Because of the limited coverage of our ground station, we can see only maximum 2 passes. Suppose you want to see more passes. So assume that Antarctica and the South Pole, we are keeping a ground station, and always the satellite is rotating in its own orbit, and Earth is rotating. Because the Earth is rotating, we are able to see maximum passes. That is the reason why we have put a station called Bharti at Antarctica. So this is the control room there at Bharti, Antarctica. So if you happen to come to GD Metla NRSC, we can have a live interaction. The students can have a live interaction with the engineers at Antarctica. So please plan your visit to GD Metla NRSC. So there are 2 modes of going to Antarctica. One is you can go through go by ship, and the second is by flight. So if you want to go by flight from Hyderabad, you have to go to Goa. From Goa again we are going to the Cape Town, South Africa. From South Africa again to Antarctica. So we have the different kind of antenna systems there. Whatever the systems what we have at Shadnagar ground station, similar kind of setup we have at Antarctica. So here you can see the whatever receiving the LEO satellites. From the LEO satellites, you are receiving the data from the DRS. That is the data remote sensing satellites. We are using the data, and from that particular DRS system is there. From there, it is going to the DCS antenna, data communication antenna, and from that antenna again it is transmitting. It is uplinking the data to a geostationary satellite. From geostationary satellite again it is transmitting and downlinking, and we are receiving the data at Shadnagar. So whatever data we are receiving from the LEO satellites at Antarctica, directly they will be dumping the they will dumping the data, that is uplinking and downlinking, and finally we are getting the data at Shadnagar. Next. So there in Antarctica you have 8 months winter and 4 months summer. That means, so 4 months summer means from October to March, only these 4 months only we will be able to go to Antarctica. Other winter it is very, very difficult. The temperature is minus 65 degrees. Suppose you want to go out for doing some kind of maintenance, you require this kind of suit to be worn, otherwise you will freeze to death. Next. So these are the mammals. We have very limited mammals like birds. We have the skua, petrel and the emperor penguin. But whereas in the Arctic Circle, we have more variety of birds. Next. And very few mammals like the minke whale, and we have the ice fish and all. But polar bear is missing here. Antarctica, you don't have polar bear, but in Arctic Circle, you have polar bear. And beautiful aurora lights. So how this happens is when the magnetic particles are striking the kind of sunlight, this kind of aurora comes. So particularly in the North Pole and South Pole, you will be able to see these beautiful lights. So So till now we have talked about the remote sensing satellites. Now coming to the navigation satellites. As you are now aware, so we have the global kind of navigation satellites. These are the list of the regional satellites available and the global satellites available. We have our Indian constellation of satellites that is called the NAVIC, and the US is having the GPS. So all your mobiles what you're using, they are using the GPS signal. So in the GPS signal, you have two different modes. You have the course acquisition mode, you have the precision mode. So your mobiles have the course acquisition mode signal. It is a free of cost, you are able to receive that particular thing, but the precision mode is not enabled in that. It is only meant for the strategic purposes only. And again, Russia also has a global kind of constellation of satellites called the GLONASS. Then Japan has the QZSS. Then the China has the Baidu. That is also a global kind of navigation satellite system. Then similarly, Galileo is there. Then also for fans, we have the Doris. So to the right side, you can see the GPS constellation of satellites. So why this particular configuration is like achieved? That means one particular orbit, one particular plane, you have 4 satellites. Second plane again, you have 4 satellites. Third plane again, you have 4 satellites. Like this, 7 planes are there. So 7 into 4, 28. So this particular configuration is made such that any person on Earth, 24/7, 365 days, whether it's in Hyderabad, whether it's in the top of the Amazon in the mid of the Amazon jungle, is in top of the Himalayas also, he'll be able to see minimum of 3 satellites. Why 3 satellites means? Position, navigation and timing for navigation purpose. And to the left side you can see the IRNSS, our Indian constellation of satellites. About 7 satellites are there, NAVIC satellites are there, that is used for our timing purpose and for our navigation purpose. The military is, our strategic military is using these particular NAVIC satellites. So coming to the applications of the different kind of remote sensing satellites. For example, I will tell you a small example, forestry for example. Okay. Now assume that in 1960s, what is the volume of forest? Now the continuous deforestation is going on. Now presently, what is the kind of volume of forest? Okay, so you can have a difference, that you can find out the difference. Not only difference, you can classify the forest also. Whether it is a deciduous forest, whether it is a coniferous forest, whether it is a thick forest, whether it is a thin forest, that kind of classification also you can do with the help of the satellite data, whatever we have. For example, the water resources. During the winters, what happened? Lot of ice is accumulated on the Himalayan region. So you can have an estimate that during the summer how much ice is going to melt and the water which can be collected in the dams. Such kind of assessment also can be done with the help of the remote sensing satellite data. And also the town planning, the urban sprawl it is called, urban sprawl. We have a high resolution data. The Cartosat or the Cartosat 2, we have less than in few meters and centimeters resolution of the imagery we are going to get. So because of the advent of the technology, we are having very good resolution, centimeter resolution. For example, a stick has fallen on the ground. So from a height of around 600 kilometers, we should be able to distinguish whether that is a stick or whether it is a pencil or whether it is a pen. So such kind of technology is available right now. So this is, first of all, I would like to tell that I am from the outreach facility, NRSA, and our group director, Fyzy sir also is available here. And this is our building. This is our building, outreach building. You can see the 2.4 meter antenna and the rocket model what you are seeing. So this is a facility what we have. So the faculty of Gurunanak, they can plan a visit to the outreach facility. Next. And this is the virtual ground station, or what we call the real-time streaming of the remote sensing satellites. So for students and all, we don't permit to go at Shadnagar. So what we did is, we brought this facility. You can see the real-time tracking of the satellite passes. You can see the real-time data. You can see the antenna tracking. This kind of facility is available. So if you happen to come to GD Metla, you can see the real-time tracking, and also the station control computer countdown also you can see. We can have a very good information about regarding the ground station. Next. And these are some of the display models what we have. Next. Yeah, this is the, next. So this is the Space on Wheels bus. So presently, the Space on Wheels bus is like going around in the northern India, and this particular bus is very useful, particularly for children on schools, government schools, the rural schools. So this bus can go to the rural schools and to different distance villages and colleges, so that we have that entire fleet of the models, the scale models, the different kind of technologies. It can depict the total technology what we have in this, this is fitted in the bus, and the children can benefit from this. Next. Now coming to the students, engineering students. This is very important part for you. So those who are interested in doing their project work, or those who are interested in doing the internship there at NRSC. So you can note down the email address. The email address is student@nrsc.gov.in. Student@nrsc.gov.in. And you should be like have completed a 4th year first sem. And after 4th year first sem, you have some time. So maybe 2-3 months time will be that. So during that time, you can come down to our place and you can do the project work. It is a duration of 3 months. And project work is duration of 3 months. And the internship is 45 days. So either of that you can do. So this will be like a value addition. So when you go for a job outside, so when you do a project at NRSC, it will be kind of value addition for you. Okay, so that is the advantage. So next. So these are the documents to be submitted. You can take a screenshot if you want. Next. And those who after completing your engineering degree, so now lot of vacancies are there. People are retiring in ISRO. So lot many vacancies. So you need to write an exam called the ICRB, ISRO Central Recruitment Board. Please note down. ISRO Central Recruitment Board exam is being conducted in in the month of January, February, and also in the mid sometimes, and also in the end year. So you can go to that particular websites, isro.gov.in, and also to nrc.gov.in. So any branch of engineering, whether it is mechanical, electrical, computer science, electrical engineering, or data science, AI and ML, anything. So all the core fields ISRO is taking, because we have different centers, different specializations are required. Not only computer science, we have other core subject areas also. Next. And you may be having your brothers and sisters who are like ninth class pass. So in this January or February, you are going to have a program. It is called the Yuvika program, Yuvika 2025. Please tell your brothers and sisters to apply for this program. It is a very good program. It is a 2-week program, and it is called the Young Scientist program. Okay, Young Scientist program. So it is in-house program at NRSC Balanagar. So total around 450 candidates will be selected in the entire India. Out of that, 50 will be coming at NRSC Hyderabad. Okay, please tell your brothers and sisters who are 9th class pass are going into the 10th class. Next. Thank you very much once again.